Hi everybody, Grandad here again. What am I up to today? Well, today I'm doing a little follow-up video to the last one I did, and I was in that video I was making a Tesla musical coil. Now, unfortunately, the build didn't go very good and it didn't actually work, so I was a bit disappointed in that, and so I fiddled with it a bit after, and to my surprise, I managed to get it to work, but it only worked for about 30 seconds and then it sort of packed in on me. So this little thing here, this little Tesla coil, made by Nikola Tesla, or developed by him, invented by him, they call a Tesla coil. But strictly speaking, this isn't exactly what Nikola Tesla actually designed. This is what they call a Slayer exciter circuit, but it works in a very similar way. Instead of using a spark gap, which Tesla used, it uses transistors to do the switching, and it's quite a clever little gadget. And I bought this. It cost me about £22 because I got this extra little bit with it, which I think I showed on the video when I was making it. And unfortunately, as I say, it didn't work. But it cost me quite a lot of money. But and I'm a bit disappointed that it didn't work. So in order to sort of correct that a little bit, I invested a little bit more money, another £5, and bought another one from another supplier. Now this one I put together in exactly the same way as the first one. And it sort of works perfectly, I think. So this is the musical Tesla coil, or the exciter coil. Now, Nikola Tesla was a very interesting man, and he doesn't get credit for all the things that he invented. He was actually a Serbian. He was a Serbian American. He was educated in Serbia, and he went across to America as an immigrant. Arrived in America with very little money, introduction to an electrical company, but he had very little money, and he was an immigrant, but he became a fully fledged American, so they call him a Serbian American. Now, he was very clever. In fact, he was a genius. I believe he was. He was one of these people that was able to, he had a photographic memory. He could remember all his circuits and different things. He trained as an electrical engineer, an electrician, and a mechanical engineer. And he was also a thing they call a futurist. Now, a futurist is someone that can see into the future and predict what's likely to happen. And some of his inventions that he invented, and he patented over 100, maybe 200 patents on different things that he invented. One of the main things that he sort of pioneered and invented was electricity. Back in the day was very, not heard of hardly. People are still using candles, because this is going back a long way. I mean, Nikola Tesla died in 1943 at the age of 88. So that was several years before I was born. So it was back in the 1800s where he was doing his work. And electricity was very new. People didn't have electricity. They used gas and they used candles. So electricity wasn't really understood. But he understood it, and he was very clever with it. And he believed that he could invent things which would power the world with electricity wherever he wanted to be on the earth. And he was more or less right. I mean, he was very, very right in a lot of things that he said and did. Now, one of the things that he pioneered was electricity used to be what they call direct current from dynamos and generators and things like that. Now, direct current was all very well, it worked, but you had to have very heavy cables, and you couldn't transmit it very far. You had to have stations every so far, and these took up a lot of room in cities and places, so it wasn't very efficient for transporting electricity around. It was safe, but it wasn't very efficient. Now, he pioneered the use of a thing he called alternating current. Now, alternating current is far different, and it was able to pump electricity for miles and miles and miles with little effort. And then you'd have transformers to bring it down into your homes. But it was dangerous. I mean, electricity is dangerous. Everybody knows electricity is dangerous. And so it was dangerous, and for a long time there was a big battle between him and another company, because he went to work for an electrical company, and he sort of pioneered this alternating current. And he was involved in the battle of the currents, as they call it, and eventually he won. And of course AC is what we use today. Everywhere all over the world AC current is worked. Now another thing that he invented was the induction motor. He invented a motor that would work on his AC current, and it was a very interesting motor because it didn't use brushes. I mean, motors in the early days had brushes on them and sparks going everywhere, and a rotor arm and all this sort of things, and they needed all sorts of armatures and different things, and they were prone to setting fire and bursting into flames and doing all sorts of things. But he invented an induction motor that would work without brushes, no friction, nothing rubbing, no sparks, and a very, very efficient motor it is. And we use those induction motors everywhere, all over the place. So he was very keen on induction motor work. And he sort of pioneered that. Now, another thing that he invented was the remote control. At one time, you know, we use a lot of remote controls all over the place now with televisions and different things. And he pioneered that. He actually invented a boat. He had a little motorboat, and he was able to power it by electricity using radio waves and whatever he called it at the time. And it was a remote control, and people didn't believe it. They saw it driving around and on a lake and steering about, and the motor running, and they didn't believe it. They made him take it apart to make sure there was no animal inside or something inside steering it or something. So that was a really remarkable invention that he made, and he made a great many more. I mean, I can't remember all the things that he invented, but he's a very famous man. And if you're interested in Nikola Tesla, because I say he didn't make a lot of money. I mean, he wasn't interested in money. He was more interested in science and doing his electricity. And that's really what he wanted to do. And he wanted to power the world for free. And that wasn't very good for the electrical companies who wanted to charge everybody money to. But he wasn't interested in money. In fact, it's just as well, because he never made a lot of money. And he was a very handsome man. Now, I got some pictures of him, but unfortunately, I'm not able to show them on this particular video for reasons of the cameras didn't work for me this time. But anyway, I'm not able to show you a picture, but if you look up on the internet, you'll find articles and videos and all sorts of things on Nikola Tesla. And he was quite a remarkable man, and he doesn't get the credit that he was due for inventing the things that he did. And he really was a wonderful man and very, very, very clever. Now, he was a bit eccentric. He had a fascination with numbers. And number 3, I think, was a number that he wanted. And he always lived in hotel rooms. He never married. He did fall in love with somebody, but she was already married, so that was no good. And he never really bothered much about women or family. So it was unfortunate that because he lived in a hotel and he was a bit of a recluse, and he even got to talking to pigeons and looking after pigeons, and one of his pigeons died, he was very upset. And so he was a very strange sort of character. He used to walk around 3 times around the block before he'd go into the hotel. And so he's got a lot of superstitions and little quirky ways. And so people thought he was a bit crazy, I suppose. I don't know. But it was very sad. I think, as I say, he died at about 88. And there was nobody with him. He was found in his hotel room dead from a coronary heart attack or something like that. And I think he'd been knocked down by a taxi before... and injured shortly before he actually died, but that was maybe something to do with it, I don't know. But anyway, he died, and it was 3 days before they found him, which was very sad. There's somebody of such outstanding cleverness, and you know, did a lot for people, that he should die in such a mundane manner. And you know, it's really, really poor. And if you look in history books, I mean, maybe in America he's more thought of because he was an American. But certainly in England, we talk about all the different people that invented electricity. I can't remember the names of them now, but all sorts of Edison and different people, all names of famous electricians. But we never hear very much about Nikola Tesla. So I want you to go and look up Nikola Tesla and find out all about him. Now, getting back to this little coil I've made here, that is a replica of what Tesla actually invented. I'm going to make a proper Tesla coil one of the days with a spark gap, hopefully. and I've got that in the pipeline. So when I make that, I'll show that on video as well and tell you a little bit more about that. But this is a little Tesla coil. Now, I'll stand it on this little box so that it, in fact, I'll tip the camera a little bit further down. Tip it down a little bit. It's cutting me off, but that doesn't matter. So I want you to see this Tesla coil. I'll stand it on this little box. Let's put it on that way. Maybe that's too risky. I'll put it that way. Okay. Now, this is supposed to be powered by a 12 volt, by 15 to 24 volts. Now, unfortunately, I've only got a 12 volt amplifier here to work it. And because this second one doesn't plug in very good, it's a little bit awkward, but I can manage to do it. Now, I'll just show you what it actually does. When I plug it in, the two little LEDs light up. Hope you can see that. And something else happens at the top of this coil. Now, it's very faint, and you might not be able to see it, so I'll turn out this light in the hope that it will show up a little bit better. You can see now that there's a corona, a plasma coming out of the top of that little wire and sparkling about all over the place. Now that's very interesting, because if I bring to it a bulb, a neon bulb, very close, you see that? The neon bulb lights up. And very bright it is too. And there's no connection. There's no connection between that and the wire. It's just the ambient energy coming from that little spark that's lighting that bulb up. If I bring another bulb in, this is another one, very similar. I bring that in, and that lights up as well. And that's quite remarkable. And this is what Tesla thought, that he could use this ambient energy, as he called it, or radiant energy, to power lights for free all over the place. And he built big towers in order to try and prove that it could be done. Now, another bulb I've got here, I'll just turn that on for a moment. I'll just turn that off for a second, because this is high voltage, so I don't want to touch it. And I'll put this little bulb on top. This is another little bulb, which came with the original one. Now again, it's not actually touching the coil. It's just sitting on the side there. If I plug it in again, carefully, you'll see that now, if I turn the light out, I've got that lighting up. And that's quite interesting. And now this is only working on 12 volts. Now if I'd got 24 volts, this would be much brighter and far better. And the other thing, as I said, that it would do was, there's another little bulb here. I don't know whether this one will light up as well. I'll try this one. There we are. There was another one. Another little bulb being lit by this Tesla coil. This little Slayer exciter coil. Now that's very interesting. Now, I'll just unplug this because I don't like it to run very long. Partly because these heat sinks on the side here, they get very hot. And those are really hot now. So I'm just going to leave it over there to cool down, because I don't want to damage it. Now, another thing, I'll just put the light back up again now, just so you can see me a bit better. And I'll bring this in. Now, you may know what this is. This is another interesting piece of apparatus. And this has its own plug. Now this is what is known as a plasma ball. Now if I turn that on and bring it into focus, I'll turn the light out again because it's quite spectacular. Very interesting little thing. I had this for Christmas, but strangely enough it works on the same principle. Now you can put your hand on it and the sparks dance about. I can't feel anything because I'm insulated by the glass, which is just as well. But the interesting thing about this is if I bring the light in, one of the lights in that I had before, you'll see that they light up as well. So the same electricity is coming out of that ball and landed on this bulb and making it light up. And that works quite well. And I'll just try this other bulb while I've got it out. Which is very interesting. Now another thing about this one, this is a musical thing as well. Now if I move it across to this position, and you'll notice every time I speak, it flashes on and off. Now this is very useful if you've got a disco or something and you plays music, because every time the music every time the music comes on, the plasma ball will light up. Now, this is very interesting. Now, another thing I've discovered as a result of playing with this plasma ball is that if you get a little bit of tin foil, I got a little bit of tin foil here, and you put it on top, I don't have to put it on top, but I'll put it on top, and just stick it down there like that, on top of this plasma ball, and switch it on. Now this acts, and it's sending a blue light up there now. I don't know whether that shows up. I'll put the light out just to show that that main light is dancing around on the top of that coil. Now, again, if I bring the bulbs in, you'll see that they light up. And if I touch them on, I don't know whether they light up quite well. Now, another thing you may notice is the sparks. I don't know whether you'll see that. I hope you can, but there's sparks coming off the tin foil onto the bulb. I'll just put the other one across like that, and again it lights up and sparks. Now I have noticed that if you touch that, you get electric shock, because this thing is acting as a what do they call it now? Not a condenser, it's something like that. I can't think what it is. It may come to me. And if you touch it, I don't know whether you noticed there, but I got a spark and an electric shock from the top of this ball. And it's quite a tickle. Quite a tickle there. So it's very interesting to... I don't think it's dangerous. It's not a very big electric shock. But this is acting as a... what do they call them? Because of course electricity is on the inside, and then you've got the insulator, and you've got another conducting material on the outside. So it's forming what they call, what do they call it? This is always the way. I really ought to make notes, because I don't remember what they call things. And when I need to know, I can't remember. But it makes another type of electrical conductor, and it brings electrical current through. Now, as I say, it's not dangerous. Now, I wouldn't recommend that you actually do this in the interest of safety. I wouldn't want children to buy one of these and, you know, get electrocuting themselves. It's only a tickle. It doesn't really hurt you. But I don't think it's dangerous. But it was just interesting that by putting this bit of tin foil on the top, you turn this plasma ball into a... oh, what on earth is the name of it? I don't think it's called a condenser. It's something like that. Capacitor, that's what it is. It turns it into a capacitor. There we go, I remembered in the end. It turns it into a capacitor, and therefore it transmits electricity through. And that's why I got the bulb's lit a little bit better, not a lot, but a little bit better. And I got a spark and a little electric shock, which didn't really hurt me. You get a far more bigger shock of Tesla coils, I'm sure, when I make one, or one of the other things I'm going to make, a Van de Graaff machine and one or two other bits of electrical equipment. which I'm hoping to do in the future. So for today, this is my little follow-up video to the fail that I had before, and I hope you found it interesting. If you did, please subscribe and like my videos, and leave a comment if you didn't like it. At least I get a contact, I know what's going on, and I'll try and make better videos. And if you know anything about these things that make them more interesting, let me know that as well. But I find it very interesting, and I'm working on electricity at the moment. As you know, I'm very keen on science, but I'm working on electricity, and I'm going to make some kits up of different things, and I hope to show them in the future. So until we meet again, and I bring you something else interesting, hopefully, it's Grandad wishing you all well, and leave a like if you can, and I'll see you again next time. Bye-bye now. Bye-bye now.